Welcome to all of you. In this session, we are going to go through the program for adding 2 bytes of data and to store that in a register. Let us go through the statement. Write an ALP to add the byte in the RAM at 34H and 35H. Store the result in the register R5, that is LSB part of the result, and R6 MSB part of the result using indirect addressing mode. So the values will be available in the memory location 34H and the 35H, and after performing the addition we will be storing the result in R5 and R6 registers, and we will be making use of the indirect addressing mode for this purpose. Now let us go through the program. So first instruction, starting from move instruction. So move R0 comma hash 0x34. So R0 is being used as memory pointer. Therefore, we are loading that with the specified memory location 34H. You use the instructions like move R0 comma hash 34H or hash 0x34. Both of them stands with the same meaning. Then after, we are initializing the register R6 is equal to 0 because R6 holds the MSB part of the result, and we are initializing that MSB part of the result to be 0 at this instant. Now move A comma at R0. The values to be added is now there in the memory location 34 and 35, and from the memory location 34 we are taking the value and storing that into the accumulator. Then increment R0, we need to take the second value, therefore we are incrementing this memory pointer. Then move B comma at R0. Now R0 is pointing to the memory location 35H. The value stored in the 35H will be moved to the register B. Now perform the addition operation using the add instruction. Add A comma B. The contents of A and B are added and the result will be stored in the accumulator. If the result is greater than FFH, then there is a generation of the carry. Still 8-bit of the data will be stored in the accumulator. If any carry generated, we are going to verify that in this instruction. Jump if no carry to skip. That means if the result is not greater than the FF value, then carry will not be generated. Then we need to move to this skip label to this instruction. In case if carry is generated, that is addition of two values is greater than FF, in such a case we are going to increment R6 by value 1, and then we are going to store the remaining part of the result, the LSB part of the result that was available in A, to the register R5. Now as per the question, R5 now holds the LSB part of the result and R6 holds the MSB part of the result. Then terminate the execution. Let us go through the simulation of this program. In the simulation, so here is the program. So I have built the program and now ready for execution. So now from this point we are doing the execution. So first let us store two values to the memory location 0x34 and 35. So here is the memory location. So to this memory location I am storing the simple values. So one I am storing it as 03H and another value I am storing it as 05H, so that the answer can be verifiable easily. So now we are having two values. Now let us start with the execution. So first move R0 comma 0x34 to the register R0. It will be loaded with the value 34H, so that you can observe now. So now R0 is loaded with 34. Now R6, register R6 that holds the MSB part of the result, we need to initialize that to the value 0. Now executing. So now it has already initialized to 0, but again it is rewriting that. Now move the first value from the memory location pointed by R0, that is 0x34H, to the register A. Now register A contains the value 0. Now it has to be updated with the value 03H. Now accumulator has got updated. Now I need to get the next value, that is 05H. For that I need to increment the memory pointer R0. So it is now incrementing, become 35. Now move the second value to the register B. So now it has got updated, register B. Add those two values. As we can observe, result will be stored in the register A. Make an observation of that. So now the answer is available in the accumulator. So in this case, no carry is generated. Since the answer is less than the value FF, it is not greater than that. Therefore, so no carry is generated. So R6 will be retained at its value 00H only. You can observe. So the execution will skip from this instruction next to this instruction, as you can observe. Now make observation of that. So execution has skipped that increment instruction. Now we can terminate the execution. Now let us take one more example. So before getting into that example, so you have to observe the result now available LSP in R5. That is what the observation. So R5, I need to execute one more step. R5, now it is having the value 08. Now R6 is equal to 00. Now the answer can be treated as 0008 is our answer. So where LSP is stored in register R5, MSP is stored in the register R6. Now let's take one more example where we are going to have the value, that is the answer, getting more than FF value. Now I'll just go to restart CPU. So execution has got restarted. I load the value here as FF itself, 0 FFH one value, 0 FFH another value. So two values I am storing. Addition of these two values is obviously greater than FFH. So carry will be generated here. So keep observing the changes in the registers. So I will be just using the step over. So changes we can observe. So procedurally same as before, but in this case carry is generated. That's what the part of observation required. Now as you can observe, sum of the values FF plus FF is greater than FF. So that you can observe. LSP is FE, LSP is FE, that you can observe. Carry is generated, that can be verified. Here in the program status word, CY register is now equal to 1. That means carry has been generated from this addition. So the R6 will get incremented by value 1. So now R6 has incremented by value 1. Then after, store the LSP part which is there in the accumulator to the register R5. So store that to the register R5. Now the answer is 01FE is the answer. So now I can stop this execution over here. So you can make use of any other data and make a cross validation with few more examples. Thanks for joining.